Okay, so here's section 13.4. We start with our Common Core quote. In grade 6 Common Core, we find that students should represent three-dimensional figures using nets made of rectangles and triangles, as in chapter 11. We did some of those. And use the nets to find surface area of these figures. That's what this is all about, surface area. So this is a grade 6 topic. So we certainly want to become a master of this material because this will be something that we're qualified to teach 6th graders about. All right, surface area of a cylinder. What's a cylinder? Well, that's a cylinder. A cylinder is basically like a soda can, and we want to figure out surface area. So just the surface, not the volume inside. That's the next section when we do volume inside of an object. But we're just doing the surface, like all the tin can around the sides and the top and the bottom. So you can see we're taking this right circular cylinder. Remember, right just means it goes straight up and down. It's a 90-degree angle to the ground here. It's straight up. It's not like a leaning soda can. That would be not a right. That'd be one that's not right. It's not a 90-degree angle to the ground. So, okay, so we're talking about a right circular cylinder, soda can that goes straight up. We want to find the surface area, all the area on the surface. So the surface involves the top and the bottom, which are circles, right? The top and the bottom of the soda can are circles. And then the sides, you can see see how they're cutting the side open here and then unrolling it. This is the sides. It becomes a big rectangle, doesn't it? When you cut open the sides and unroll it, it's a big rectangle. And so what's the area of a circle? Let's start with the top. Pi r squared. Remember, we already have the area formula of the circle. And this is pi r squared as well. So the surface area for this, all the surface area is going to be 2 pi r squared because that's the top and the bottom. See why we have that 2 there? Because there's a top and a bottom. 2 pi r squared, circle on the top, circle on the bottom. And then what's the area of the sides here, which was the sides? Well, when you unroll that rectangle, see how the height is still the height. That hasn't changed. But what is going to be this this width here? You know, let me draw that a little bit better. How wide, because this is a rectangle, right? And a rectangle, the area of a rectangle is one side times the other, length times width. So, right, the area of this rectangle is length times width. So we have one side is h, because that's just the height of the original soda can before we cut it and opened up the sides. But how wide is this? What is this width here? Well, you can see it's 2 pi r. Where are they getting that? Well, because that's how far around, right here, how far around the circular top was, 2 pi r. Don't confuse that with the area formula. So there's 2 different formulas that are very similar. Area, which means space in the middle of a circle, is pi r squared. Same thing down here. Space in the middle of a circle is pi r squared. So that's all the area for the circle of the top and the bottom. But what I'm doing right here, this is circumference. Circumference. 2 pi r. I'll write the whole word out. Circumference. 2 pi r. That's just how far around the circular edge. That's what actually ends up becoming the width. Can you see it? So starting right here, going around that circular edge, when we make the cut right here and open it up, that all becomes the width, doesn't it? That's where we get the 2 pi r right here. That's the width. Okay, so the area of the sides is one side, height, times the other side, 2 pi r. So it's height times 2 pi r. That's the area of the sides, because it's a big rectangle when you open it up, and it's just one side times the other side. Height times 2 pi r. So the total surface area is going to be 2 pi r squared plus h 2 pi r, because that's for the sides. So the 2 pi r squared for the top and the bottom, the two circles, the 2 pi r squareds, and the h 2 pi r for the sides. Usually it's written this way, 2 pi r squared, and they put that 2 in the front. It doesn't really matter where it is. 2 pi r h. Either way, it's totally the same thing. So that's how we find the surface area of a soda can. All the outside surfaces, the top and the bottom circle, and the sides, which makes a big rectangle. Next, we have a formula for a cone. Surface area of a cone. This is an interesting one. You can see the surface area formula there. It's got a circle on the bottom, so the bottom being a circle, the area of a circle, the space inside of a circle, you know, that's pi r squared. But what are the sides? It's kind of weird, isn't it? The sides. The formula for the sides is actually tricky. It's pi r l, where this is L. Notice here, it's the slant. L is the slant height. So it's not the real height. It's, you know, the real height is straight down here. This would be the real height, right? Straight down to the ground. L equals slant height. It's what we call the slant height. It's going down the slant there. L is the slant height, and that's how you figure out the area of the sides. So total area, the surface area for the whole thing, it's going to be pi r squared, which is the area of the circle on the bottom, plus pi r l, which is the sides, where L is the slant height. Kind of an interesting one. And then down here we have the surface area of a sphere. We'll just give that formula straight. It's 4 pi r squared, surface area of a sphere. That's all the way around the outside of a big ball. So you can do that to find the surface of the earth or the surface of a basketball. It's all the way around the outside the surface of a big ball, a sphere. So you can put all these formulas on your 3x5 card for the next exam. All right, let's look at the homework. So here we go. We're wanting to figure out the surface area, right here, surface area of this cube. Okay, well, the cube has 6 sides, right? We have the bottom here. Let's start with the bottom. The bottom, what's the area of the bottom? Well, it's 3 by 3. So we have 3 times 3 for the bottom. That's the area. It's a square on the bottom. And it's the same square on the top, isn't it? It's 3 by 3 on the top. And if we keep going here, it's 3 by 3 on the right side. The right side is 3 by 3. We're just going to add up the 6 sides. The area of all 6 sides. The left side is also 3 by 3. I think you're getting the pattern. Plus, what do we have left? We have the front and the back. So we have the back, which is also 3 by 3, and the front, which is right here, 3 by 3. So it's 6 3 by 3 rectangles. So that's 9 plus 9 plus 9 plus 9 plus 9 plus 9, 6 times 9. So this would be 54. And what are the units on that? Well, it's area, remember? Even though it's a 3-dimensional figure, we're breaking it all apart, right? This is a 3 by 3 square. Each of these are 3 by 3 squares. Like we're breaking it all apart to paint it or something and then put it back together afterwards. We're just painting all the squares. We're just going to paint this surface, paint this. We're just painting all these rectangles. And so it's just square centimeters. It's not cubic. That'll be the next section when we do volume and we fill something up. But now we're just doing the area, the surface area. So it's still area, it's still square units throughout this section. And then B, come down here on B. This is a soda can, right? Right circular cylinder. We just talked about that. The surface area is 2 pi r squared plus 2 pi r h. If you look back here, right here, 2 pi r squared plus 2 pi r h. So 2 pi r squared plus 2 pi r h. This is for the top and bottom. Surface on the top, surface on the bottom, and this is for the sides, all the way around all the sides. Okay, let's figure it out. So the surface area is 2 pi. What's the radius of this shape? Radius is from the middle to the edge. It's that 5 right there, isn't it? 2 pi. What's the radius? Again, 5. And what's the height? Well, this is the height, the 11. So that's going to be 2 times 5 squared. 5 squared is 25. 2 times 25, 50 pi plus 2 times 5 is 10 times 11 is 110 pi. So you just multiply the numbers on your calculator if you want. Multiply the numbers, and then they have a pi with them. So add that up. It's going to be 160 pi. And so that's how they want the answer. See how they say down here, exact answer using using pi as needed. So they want 160 pi. In other words, they don't want me to use my calculator and get a decimal. The decimal would go forever, and we'd have to round it, so it wouldn't be exact. So when they say they want an exact answer using pi, they want you to leave it 160 pi. What are the units? Again, it's area, so it's square units. It's square centimeters. There we go. All right, C, right rectangular prism. So again, surface area. This is going to be 6 rectangles again. It's got 6 sides. We're just going to add up the 6 sides: the top, the bottom, the right, the left, the front, the back. Same kind of thing. Let's start with the bottom. So here's the bottom. How much area in that bottom? It's 8 by 2 rectangle. So 8 by 2 plus the top. Well, the top is identical, isn't it? 8 by 2. Okay, let's go for the right side now. So what's the right side? It's 2 by 4 rectangle. And the left side, same thing, it's identical. 2 by 4, 8 by 2, 8 by 2, 2 by 4, 2 by 4. And last, we have the front and the back. Front and the back. So the front here is 8 by 4. See this 4 here? It's 8 by 4. And the back is the same, 8 by 4. So we just add all those up. What is it? 16. 16. 2 times 4 is 8. 8. 4 times 8, 32. 32. Use your calculator. See, what is that going to be? 112. And it's square centimeters. There we go, 112 square centimeters. All right, so for those big boxes, those right rectangular prisms, we just add up the 6 sides. Okay, coming down here for a sphere, a big ball. If we look back for the surface area formula, for a big ball, there it is, 4 pi r squared. So it's 4 pi r squared. So that's 4 times pi, and what's the radius? Well, there's the radius, 12 from the middle to the edge, that's the radius. So that's 4 times pi times 144. Use your calculator, that's going to be 576 pi. Multiply 4 times 144. They want you just to leave the pi, and that again is square centimeters because it's area, right? We're not filling up the middle of the ball, we're just talking about the surface, all the material around the outside of the ball, surface area, so it's area, square units. And then E, we have a right circular cone. Right circular cone. Okay, this one will be a little more tricky. Okay, so to find the surface area of this right circular cone, let's go back and get the surface area formula. So here it is. So surface area for a right circular cone right there, pi r squared for the bottom, and pi r l for the sides, where L, notice, is the slant height. So pi r squared for the bottom plus pi r l for the sides. Okay, so we know the radius, right? This is the r here, the radius from the middle to the edge of the circle. So the surface area is pi times the radius, which is 12 squared, plus pi times the radius again, 12 times L. Now, we don't have L. This is L here, right? It's the slant height. It's the height from there. It's the length. It's the length from there to there. It's called the slant height. Because it's not real height, it's down the slant. The real height is the 9. This is the actual height of the cone, is 9. But we need the slant height to find the surface area. All right, so how are we going to find that L, that slant height? Can you see it? We have a right triangle, don't we? So we're going to have to find L, we're going to have to do the Pythagorean theorem, aren't we? So to find L, we're going to have to do a squared plus b squared is c squared. The c is the L, because that's the side across from the right angle. So that'll be the L squared. The a and the b are the 9 and the 12. They're the other two sides of the triangle. 9 squared plus 12 squared, so 81 plus 144 is L squared. What's that going to be? That's going to be 225. L squared, and then to finish solving for L, we root both sides, and so L equals 15. All right, so we have the slant height now, so now we bring that back. The slant height is 15, so bring that and plug it in right there to the formula for surface area. Now we know the slant height, so now we can calculate the surface area. So this is going to be 144 pi. I just squared that 12. 12 squared is 144 plus 12 times 15. Let's find out what that is. That's 180 on your calculator, 180 pi. And then they add up to be 324 pi. So there it is, 324 pi, again, square centimeters. So it was a little more work. We had to go find L, the slant height, using the Pythagorean theorem, get L, and then bring it back and plug it into the surface area formula. Okay, question number 2. How many liters of paint must you buy to paint the walls of a rectangular prism-shaped room that is 19 by 14 with a ceiling height of 8 if 1 liter of paint covers 40 square meters? Assume there are no doors or windows and the paint comes in 1 liter cans. Okay, so how are we going to do that? So let's draw this shape first off. We can think about how to draw it. It's I'm going to draw like a rectangle, and then another rectangle, whoops, down below it. And then we're going to connect those with straight sides. So there's the rectangular room that we're talking about. And I'll put the dimensions on there. The room is 19 by 14, so maybe it's 19 this way, 14 that way. A ceiling height of 8, so this is 8, the ceiling height. So there's the room, 19 by 14 with an 8-foot ceiling height, or meters. These are all meters. So what we need, if we're going to paint all the walls, we need the surface area. So the surface area is going to be 6 sides, isn't it? We're counting. Wait. How much must you buy to paint the walls of the rectangle? Oh, just the walls, not the ceiling. Yeah, okay, just the walls. So not 6 sides. We're not gonna paint the ceiling and the floor. Of course, that makes sense. Just the 4 sides, not the ceiling and the floor. Right? Paint the walls. So 4 sides. So what are the 4 sides? Well, we have the right side here, which is 14 by 8, isn't it? So we have the right side, 14 by 8, plus the left side over here, which is the same, 14 by 8. Plus we have the front wall here, which is what, 19 by 8, isn't it? And then we have the back, which is the same as the front, same exact size and dimensions, 19 by 8. So 14 by 8, 14 by 8, 19 by 8, 19 by 8. So if you add all those up on your calculator, so I'm going to do right now too, 14 by 8. I'm getting 528. Now that's square meters, right? Because those are all meters. It's area, square meters. 528 square meters. Now, we're ready for the second part. 1 liter of paint covers 40 square meters. 1 liter of paint covers 40 square meters. So how many liters do we need? How many liters of paint do we need? How are we going to figure that out? Well, we got to take the 528 and divide by 40, don't we? And I'm getting 13.2 liters of paint that are needed. So, can you go to the store and remember they say the paint comes in 1 liter cans. Can you go to the store and say, I want 13 cans and 0.2 of a can, please? No, obviously. How many? So that's why they say round up to the nearest integer. You're going to have to buy 14 liters of paint. 13.2, you're going to have to round it up to 14 liters of paint. See why we round up? You can't just buy 13 liters. You'll come up short. You're going to have to round up so you have enough paint. So 14 liters of paint would be needed, 14 cans of paint to paint all those walls. Good. Okay, let's go on to number 3 here. Number 3, a soup can has a 4 1/8 inch diameter and is 4 inches tall. What is the area of the paper that will be used to make the label of the can if the paper covers the entire lateral surface area? Okay, so what we're talking about is, so this problem is over there. So we're talking about a soup can like this. Oops, my circle got a little big down there. So we have a soup can, and they're saying it has a diameter 4 1/8 inches tall. So that means from here to here is 4 1/8. What I would do is I'd take my calculator real quick, and I would go 1 divided by 8, and it'll tell you 0.125. So this is 4.125. Let me put it right here. 4.125 is the diameter all the way across. And you know what we always need is the radius. So from the middle to the edge, from here to here, is going to be half of that. So that's the radius. I'm just going to divide this by 2. And I'm getting 2.0625. That's right, because the radius is half of the diameter. So if I take the 4.125 and divide by 2, then I get the radius, which is how far from the middle of the circle to the edge of the circle. That's what we need in all of our formulas. And it's 4 inches tall. So that means this is 4 from here to here is 4 inches tall. Okay. So now they want us to figure out, they're saying, what is the area of the paper that goes around the sides for the label? Let's go back to the surface area formula for a soda can shape, right circular cylinder. So go back here. Here it is. Surface area is 2 pi r squared for the top and the bottom, and it's 2 pi r h for the sides. Well, we only have the sides. We're only putting the label around the sides, not the top and the bottom. So we just need the 2 pi r h part of the surface area. So the surface area of the sides is 2 pi r h. That's all we need. We don't need the top and the bottom. We don't need the 2 pi r squared for the top and the bottom. So how do we figure this out? So it's going to be 2 times pi, the radius. Oh, and they told us right here to plug in for pi. See how they say use this for pi? So 3.14159 for pi. And then the radius, we just figured out, is right here. 2.0625, and then the height, they told us there's the height 4. So there we go. Let's multiply those numbers together. And I'm getting 51.836. It goes on and on and on. 235. But they want me to round. Notice round to 2 decimal places. So remember how the rounding works. You circle the second place. You look 1 to the right. If the 1 to the right of that is 5 or more, it's 6. So you round up. So 0.84. And that is, again, what units? Square inches. I don't know if you notice these were inches and inches. Area is square units. So it's square inches. There we go. All right, so now number 4. We're supposed to find the surface area of that shape right there. How are we going to find the surface area of that shape? Well, it's a right square pyramid. So that means we have, let's start, so the surface area is going to be, the bottom plus the 4 triangle sides. So it's the bottom plus the 4 triangle sides. So, okay, what kind of shape is the bottom? The bottom is a rectangle, isn't it, or a square? So here's the bottom. That's a square. What are the dimensions? Yeah, the bottom's a square, I should say. Just look at the name over there. I didn't look close. Square. So the bottom is a square. So the square is what? find the area of a square, you got to do one side times the other side. Well, this is, they're telling us it's 3.5 and 3.5, so that must be, 3.5 plus 3.5 is 7. So it must be, from here to here must be 7. And the other side must be 7 because it's a square, right? The two sides are the same. So the area of the bottom square is 7 times 7, going to be 49. So that's the bottom, but now we need the 4 triangular sides. So how do we figure out the area of the triangular sides? Well, remember the area of a triangle is going to be 4, and then the area of a triangle is a half times base times height. Right? That's how we find the area of any triangle, half times base times height. And this, let's just look at this one right here. This is a triangle, and we have 4 of those around the pyramid. So to find the area of this triangle, we need a half times base times height. Well, we got the base here is 7. This is the base of the triangle. It's 7 all the way across the base there. And this is the height, isn't it? The height goes right down the middle at 90 degrees to the base. So this is the height, 6.5. So we go, okay, so then the surface area must be 7 times 7 for the bottom, and 4 times a half times the base, which is 7, times the height, which is 6.5. So then the surface area is 49, and then just use your calculator. For that other part, I'm getting 91, which adds up to be 140. 140, and that's square centimeters, because again it's surface area, and surface area is always square units. Okay, let's try this next one. B, right circular cylinder topped with a hemisphere. Okay, so so this last one we did a pyramid, surface area pyramid. Now we're doing the surface area of this shape. Okay, so up here we have a half of a sphere, right? A half of a ball. And so that's going to be half of the surface area formula for a sphere, which is 4 pi r squared. If you go back and find that, there it is for a sphere, 4 pi r squared. That's for a whole sphere. So this will be half of that. Okay, so that part will be half of 4 and pi, and then what's the radius? What's from the middle to the edge? That's the radius, right from the very middle of the sphere or the circle to the edge. What's that going to be? Well, notice it's 22 from here to here, so this must be 11, huh? The radius must be half that, 11. So this is 11 squared. All right, use your calculator. Half times 4 is 2 times 11 squared. I think that's 242 pi. So there's the surface area of half the sphere. Now we have the shape down here. Let's go look at that. So the shape down here is, we want this, it's a soda can shape, and the surface area is going to be the bottom circle plus the sides, but not the top. We're not going to count the area of this top because that's not really part of the outside of the object, is it? That's not the outside of the object. Where just surface area just means the parts that are outside. Like if we're painting the thing. So if we're painting the outside of this object, we'd have to paint the half a sphere dome top. We just figured that part out. We'd have to paint the bottom. We're counting the bottom, which is weird. I guess you don't really paint the bottom, but anyway, it's part of the outside. And we'd paint the sides, but not the top. So let's go back and get the formula for that. Go back to formula here. So remember how this formula works. We have, this is the top and the bottom right here. So that's why we have 2 pi r squared, because we have a pi r squared in the top and the bottom. We'll just have 1 pi r squared because we just have the bottom. And then there's the formula for the sides right there, 2 pi r h. So the sides are 2 pi r h, and the bottom is pi r squared. We don't do the 2 pi r squared because we don't have the top. Okay, so what's the radius? The radius again is the 11. And the side, 2 pi, and the radius again is 11. And what's the height? That's the 60 here, right? This is the height of the soda can part, right? The cylinder, the right circular cylinder, the soda can shape. So that's our 60. So that's a 121 pi plus 2 times 11 times 60. I'm not sure what that is. This is my calculator here. 1320 pi. Add that up. And I'm getting 1441 pi. So this plus this, add those together, because that's the half a sphere, the dome top, and then the bottom and the sides, all added together. So it's going to be 242 pi plus 1441 pi equals 1683 pi. 1683 pi, and what's the units on that? Square feet, because it's area, surface area. There we go. So that's kind of a tricky one. So we had the half a sphere on the top, we had the bottom, and we had the sides. All right, so here we have an ice cream cone kind of shape. So again, we're just counting the outside. So we have a half a sphere on the top. So that's going to be half of 4 pi r squared. Let's start with that. So that'll be a half of 4 pi. And then what's the radius? This is the radius right there, 5 times 5 squared. So that's, what's that, 50 pi. If you use your calculator, you know a half times 4 times 5 squared. 50 pi. And then we have this. Now what is this? This is the sides of a cone. We're not going to do the top of the cone because that's not part of the outside, is it? We're just doing the outside, like we're painting the outside of some statue that looks like a ice cream cone. So what's the formula for this area of the sides of the cone? Let's go back here. So here we go, the bottom and then the sides. That's what we want. There's the side of a cone, pi RL. So it's, it's equal to pi RL. Now what's the L? The L is here. It's the slant height. Remember, L is always the slant height. So first we have to find L. First, find L. How are we going to find L? Pythagorean theorem, right? A squared plus B squared is C squared, because we have this side, and this is the one across from the right angle. This is the C. So that'd be 5 squared plus 10 squared is L squared. 25 plus 100 is L squared. 125 is L squared. And then we square root it. L equals. Now, how do you simplify the square root of 125? Remember, you got to break it down with your calculator. You know 5 goes in, so divide by 5 in your calculator. You'll get 5 times 25, and then break down the 25, 5 times 5. So the square root of 125 ends up becoming 5 times 5 times 5. So that's the square root of 5 times 5 times 5. That's the inside, the guts of a 125, 5 times 5 times 5. And now remember how it works? Square roots are a 2-for-1 deal, right? So 2 5s inside sends 1 5 outside, and they're gone. So the L is 5 on the outside, 5 on the inside. 5 root 5 is the L. Okay, so all that was to find out. Now let's take that back up here. So this area is pi times R. What's the R? Well, the R is 5. Times L. What's the L? Well, we got the L right here. 5 root 5. Do that a little bit better. 5 root 5. Okay, so you multiply that all together. That's going to equal 25 root 5 pi, because the 5 times 5 makes 25, and then we have the pi and the root 5. So 25 root 5 pi. And these two are going to now add together, because we have the half sphere on the top and then the sides. So the total, bring it on down here, let me write that a little better. So the total surface area is the 50 pi from the half dome top plus 25 square root of 5 pi, which is the sides. So that's it. We just leave our answer like that. That's how they want it. Oh, and what are the units? Square centimeters, because it's area, which is square units. There we go. All right, number 5 here. They're saying approximately how much material is needed, move this here, to make the tent illustrated in the figure to the right. Both ends and the bottom should be included. So the whole, all the tent material, how much material is needed to make this tent? Well, it looks like we have a front triangle. We're going to need to, there's 5 sides altogether. There's a front triangle right here. And then back here there's a back triangle. Those are the same. Plus 3 rectangular sides, right? The sides are rectangles. It's a rectangle, so there's 3 rectangular sides that are all going to be the same shape, I think. 9 by 6, 9 by 6, 9 by 6 on that. No, actually, that's not the case. Let me be a little more careful here. So the front triangle, the back triangle, the bottom rectangle plus the 2 side rectangles, which I think will be a little different than the bottom rectangle. That's what we have to add up, those 5 sides. All right, let's do it carefully. So first off, let's start with this triangle on the front here. The front, it's a half base times height for any triangle. And the base is the 6. That's all the way across. The height is the 4. So it's a half of 6 times 4. And so half of 6 times 4, half of 24. So this is 12. This is 12, right? The back. So the front and the back are going to be the same. This triangle back here will be exactly the same. So the area of the front triangle is 12. The area of the back triangle is 12. Get that from a half times base times height. Half times 6 times 4. Half of 24, 12. Okay. And now how about the bottom rectangle? So the bottom rectangle, let's see here. So if we're looking at this rectangle here, what's the area of that rectangle? Well, rectangle is just length times width, isn't it? So that's just 9 by 6. So that's 54 plus. And now we have the two rectangles on the sides that we need to figure out how we can do that. So let's do this rectangle here. The one on the other side will be the same. I don't know if you can see that very well. It's kind of a funny color. Let me see if I do this. Yeah, it's better. So how do we find that rectangle's area? Well, again, the area of any rectangle is just length times width, and we have two of those. So we need 2 length width. Right? We have the two side rectangles. The one here and the one back here. Right? One on each side coming down for the tent. So what's the area for each of those rectangles? Let me put this one back here. So trying to find that rectangle, and then just times 2. So well, one side is 9. This side is 9 right here. Let me do that a little bit better. This side is 9 from there to there. Okay, but what is this side from there to there? Because that's the other side of the rectangle, isn't it? How are we going to figure that out? Well, do you see it? That's going to be the hypotenuse of the little right triangle. Like right here, if I put this right angle here, this is 6, so it's 3 on each side, 6 all the way across, so it's 3 on each side. This is 4, they're saying right there. So we can find the other side. You might just remember that one. 3, 4, 5. It's going to be 5. I'll just say it's C. That's going to be the C because that's across from the right angle, isn't it? So over here, find C, the side of the rectangle. So that's going to be 3 squared plus 4 squared is C squared, right? Because it's A squared plus B squared equals C squared. So that's 9 plus 16 is C squared. That's 25 is C squared. How do we solve for C? We root it. C is 5. That's what I was saying. You might remember that if we have 3, the 3, 4, 5 is a really common one. So this side must be 5. Here, this side. By the Pythagorean theorem, that side has got to be 5. Make that 5 a little better. That's got to be 5. So now we know the rectangle is 9 by 5. So it's 9 by 5. Oops. And there's 2 of those. There's 2 of these 9 by 5 rectangles, right? One on each side of the tent coming down. So if you multiply that in your calculator, I think you'll get 90. So we have the front, which is 12, and the back, which is 12, right? Front here, back here. We have the bottom rectangle, which is 54. That's the one that's on the ground. And then we have the 2 side rectangles, which together make 90. That's everything for the tent. Add that up on your calculator. And I'm getting 168, and the units would be square feet because area is always square units. All right. That was a tricky one. Now, finally, number 6, a square piece of paper, 20 centimeters on a side, is rolled to form the lateral surface area of a cylinder, and then a top and bottom are added. What is the surface area of the cylinder? Okay. So let's draw out a cylinder first off. So cylinder is, soda can shape. So there we go. And we're taking a square piece of paper. So we're taking this square, which is 20 centimeters on each side. And we're going to roll it up to make the sides. And then we'll add a circle on the top and the bottom. Okay, so if you roll it up, this 20 right here it'll become how far around the top there, won't it? That'll become the 20. Do you see that? When you roll up that square piece of paper to form the sides of the soda can, this length of 20 across will become 20 around the top or the bottom of the soda can. Okay, great. So what? Well, remember how far around a circle is the formula 2 pi r? That's not to be confused with the formula pi r squared. Remember back here when we first looked at the soda can? This one. And I wrote right here for you 2 pi r. That's the circumference. That's how far around the top. See it right here? It's going around the top of the lid. So that's not it's not area. It's not space inside of a circle. That's pi r squared. Very similar formula. But 2 pi r, the 2 has come to the front if you're just talking about how far around the edge of a circle, not this area inside the circle. So that's what we're talking about on this one. We're talking about around the edge is 20 because that's the width of the paper which goes around the edge. So that's 2 pi r. So let me take this over here. That means 2 pi r is 20. Right? Because that's the formula for around the edge of a circle called circumference. Okay, so what do we do now? Well, now we can solve for r. Remember, we always need r on all these problems. So let's solve for r. Divide by 2 pi. To solve, what am I doing this for? I'm trying, because we need r. So what is r? It's 20 over 2 pi, but remember, you always reduce fractions. This is 20 over 2 pi. 2 goes into 20 10 times, so it's 10 over pi. So the radius is 10 over pi. So that means from the middle to the edge, the radius is 10 over pi. We figured out the radius now. We need that because, now let's get back to the main problem. We need the surface area of this cylinder. And what's the surface area of a soda can, right? Circular cylinder. The whole formula. Let's go back here again. Surface area formula for the whole thing. 2 pi r squared for the top and the bottom. That's the pi r squared top and bottom. Plus 2 pi r h for the sides. So we go back and we go, okay. It's going to be pi, or 2 pi r squared for the top and the bottom circles plus the sides. And what's the sides? It's this shape. It's this rectangle. It's just 20 by 20. That's what is wrapped around, right? That's what we rolled up to be the sides. It's just 20 by 20. It's just this rectangle. This becomes the sides when we roll it up to be the sides of the soda can shape. So it's just 20 by 20. I don't even need to use the official formula, which was what, pi r, 2 pi rh. I don't need it. It's just 20 by 20 because the sides is just that rectangle, or that square. All right, so let's keep going. Now we can figure out the surface area. It's 2 pi r squared, so it's 2 pi. What's the radius? Right there, we found the radius. 10 over pi squared plus, and then 20 times 20 is 400. Okay, now we need to simplify this formula a little bit. So the surface area will be 2 pi. Now what happens when you square? Well, you square the 10 and you square the pi. So what does that mean? That means 10 times 10 and pi times pi. Squared means 2 of them, right? So 10 times 10 is 100, and pi times pi is pi squared. Pi is just a letter. It's just a Greek letter. It's the Greek P in the Greek alphabet, so we just treat it like an X or something. Pi times pi on the bottom is pi squared, and 10 times 10 on the top is 100. Okay, and now what do we do with fractions? Remember, fractions, when you have like a whole number, you put this over 1. Remember how that works? And then you can cross cancel, like pi cancels one of those pi's. In fact, let's go back and just write it as 2 pi's. You can just leave it pi times pi. That's what it is, right? Pi times pi. And then this pi will cancel one of those pi's, leaving one extra one on the bottom. And 2 will multiply the 100. So the surface area becomes 200 over a single pi, right? 2 times 100 on the top and 1 times pi on the bottom, plus 400. And there it is. There's the surface area. And the units? Square centimeters. There we go. That was kind of tricky.